Okay, you've made it to the study guide. Hopefully you've done the study guide. You should have done the study guide ahead of time. It's just a quick check to see how you've done before you take the unit exam. So write in order the first 12 perfect squares. Yeah, you should know those first 12 perfect squares. 1 times 1 is 1. Then 2 times 2. 3 times 3 is 9, followed by 16, 25, 6 times 6, 7 squared, then 80, 64, 81, 100, 121, and 144. 1 times 1, all the way to 12 times 12. Remember, when we simplify radicals, we need to look at the top and the bottom of the radical to see if we can simplify either one. So if it's a fraction like this, we're taking the square root of 25 and the square root of 100, and that gets us 5 over 10. But wait, there's more. That's the same as a half. Square root of 24, can we break it down? We'll be able to break it down. I know sometimes calculators will do that for you, but we want to see you do this. So find a perfect square in 24, namely 4, and 4 times 6 is 24. So 2 square root of 6 is the result there. Can we do the same thing with the square root of 50? Well, that's 25 and 2. 2 quarters make 50 cents. So 5 square root of 2 finishes that one off. The square root of 7 over the square root of 5. Well, neither one of those are perfect squares. So we're going to rationalize the denominator by multiplying by 1. Square root of 5 over square root of 5 is 1. This gives us the square root of 35. And you know that the square root of 5 times the square root of 5 is 5. Down to the next row here, the square root of 9 and the square root of 5. We know the square root of 9 is 3. You do too. It's the square root of 5 on the bottom. Can't have the square root of 5 on the bottom. So we'll multiply top and bottom. Now on this one, we can't multiply the 3 and the 5 together because the 3 is not inside the radical. So this is going to equal 3 square root of 5 over 5. I really like the next one, square root of 32. Now the easy way to do it is break it into 16 and 2, which becomes 4 square root of 2. However, sometimes you might not see that right away, but you do know that 4 times 8 is the square root of 32. And you do know the square root of 4 is 2. And you also know that 8 goes down even farther. Yes, you do. The square root of 8 is the square root of 4 and the square root of 2. Namely, that 2 comes down. The square root of 4 becomes 2. And the square root of 2 still stays. And because of multiplication properties, which we'll get to here in a moment, this becomes 4 square root of 2. And you are done dealing that one. How about the next one, the square root of 11 and the square root of 4? Aha. We don't know the square root of 11, but we do know the square root of 4, and it's 2 again, and that's in the denominator, and we're good with that. The square root of 21, yeah, you can break it down to the square root of 7 and 3, but guess what? Not perfect squares, so this one does not simplify, so we write the square root of 21, and we are done with that little section, everybody. Let's complete operations with square roots. If we have 3 square root of 7 squared, what that really means is it means 3 square root of 7 times 3 square root of 7, or even farther, that's the same as 3 times 3 and the square root of 7 times the square root of 7. And you know that 3 times 3 is 9. And you also know that the square root of 7 times the square root of 7 is 7. So 9 times 7, 63. Second one, 7 square root of 5 minus the square root of 20. You look at that and go, you cannot subtract those because they are different inside the radical. But guess what? Yes, you can, because the square root of 20, you know, breaks down into 4 and 5. Yes, you did, because you've done that. You've already done this. So this is 7 square root of 5 minus the square root of 4 becomes 2, 2 square root of 5, and 7 minus 2, there's 7. Take 2 away. There's your 5 square root of 5. Stay with me now. 2 square root of 10 times 4 square root of 2. When you multiply, you don't have to worry about radicals being the same. We do know that 2 times 4 is 8 and 10 times 2 is 20. We can multiply the coefficients of the radicals and then multiply what's inside the radicals. Oh, hey, look, there's 20 again. 4 and 5 again. Here comes the 8. Don't forget about the 8. So this is going to be 8. That's a 2. That's the square root of 5, and we get 16 square root of 5. Say it with me, 16 square root of 5. That's how we say that. And finally, our last one, 5 square root of 2 plus 8 square root of 2. That's 13 square root of 2. If there's a 1 in front, or if there's not anything in front of the radical, assume it's a 1. Quadratic formula time. Hey, for right now, we're going to give that to you. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And the first thing you've got to be able to do in working with this is find a, b, and c. But the problem is this, it's equal to 1. We're going to have to rewrite this by moving that 1 over by subtracting, getting it to there. A is in front of x squared, b is in front of x, and c is the constant left over. Okay. We're going to take those three numbers and we're going to apply them because on the last page, you have the same equation. And we're going to try to place the answers in simplest radical form and then round them off as well. So let's get to it. We know because it's the same problem that our A is 4 and our B is -8 and our C is -1. We'll just make a quick note of that. This is our quadratic formula right here. Let's plug things in just like you did in one of the previous concepts. So it's -b. So that's going to be -b. That negative means it's the opposite of b, plus or minus the square root of b squared. B is in parentheses. We call it the quantity squared. Minus 4 times a, which is 4, times c, which is -1, all over 2 times a. That's 2 times 4. We'll go to the right here. A negative times a negative is a positive, or the opposite of -8 is 8. -8 squared is 64, and this little portion right here, negative times a negative is positive, and 4 times 4 times 1 is 16, all over 2 times 4, which is 8. And we get there, and we get to this point where it's 8 plus or minus the square root of 80, all over 8. That's a lot of 8s in that problem. And you know what? We're almost to the point where we're going to have to use our handy dandy calculator. I shall get mine out right now. But before we do, because my graphing calculator doesn't do radicals, I'm going to have to break 80 down myself. So how does 80 break down? Well, let's show a little work off to the side. Okay, 80. Well, think money. 20 times 4. So 4 $20 bills will make 80. That'll make that 2. Oh, look, square root of 20. Square root of 20. We know the square root of 20. Square root of 20 breaks down like it's done already 2 times, 4 and 5 again. So there's 2, there's 2, there's the square root of 5. And so we get 4 square root of 5 for that part. So what we're looking at over here is this is going to become 8 plus or minus 4 square root of 5 over 8. Changing colors for a second, we need to look at this, and this, and see if they all have something in common. You bet they do. They all can be divided by 4. So that's a 2, that's a 1, and that's a 2. So our final answer is 2 plus or minus the square root of 5 all over 2. That satisfies this part right there up top. But how do we change them to a decimal? Well, recall that these are the two answers, 2 plus the square root of 5 over 2 and 2 minus the square root of 5 over 2. And you can do this a couple different ways. One is if you have a fraction key on your calculator, you can put this entire numerator in your calculator and divide it by 2, or put all of this numerator inside the parentheses and go from there. So let's see what I get. I'm going to do the parentheses away, 2 plus the square root of 5. And I'm going to cut that in half, divide it by 2. So this one to the nearest thousandths, that's 3 decimal places. Yep, you know that too. That's 2.118. And then the other one is 2 minus the square root of 5. You can also hit equals and before you divide by 2, either way. And that gives us negative 0.118. There's our 2. We've satisfied all the conditions of that. Last concept to look at, Pythagorean Theorem. We've had the situation where 2 walls are to form a right angle. So let's go ahead and draw that. We know one wall is 8 feet. Doesn't matter which one. The other one is 6 feet. I'll even label the feet on there. That's the mark for that. We want to ensure that this is going to be a right angle. So if this is a right angle, which means the room is square, how long is this right here? This is the Pythagorean theorem. We have this missing side that's called the hypotenuse. These are the legs. 6 squared plus 8 squared equals x squared. Yep, that is a squared plus b squared equals c squared. And did this on purpose because it's a very common triangle. 6 squared is 36, 8 squared is 64. This is 100 is equal to x squared. And because we're dealing with the length, x is equal to 10. And yes, it's feet. This should be 10 feet across here if that is truly a 90-degree angle. And that's important. Now we're just going to solve some equations here. So x squared plus x squared is 2x squared equals 100. We'll divide both sides by 2. And then take the square root of 50. And again, if you're going, I've already done 50. Yes, you have. That's 5 square root of 2. And this one is positive and negative because it's x squared, which means there are 2 answers. We're not worried about length. This is 16 plus x squared equals 36. We'll take the 16 away from both sides because we want x squared to be lonely. Oh my goodness, how about that? My gosh, if we could do the square root of 20, look at how many things that just come up with the square root of 20. So x here is going to be equal to plus or minus 2 square root of 5. That's 2 answers right there as well. We've got 3 square root of 5 squared. Remember, this is 3 squared, which is 9. Put that off to the side. The square root of 5 times the square root of 5 is 5. That's 45 plus 4 equals x squared. Oh, look at that. There's your 49. And taking the square root gives you x equals plus or minus just 7, because we know the square root of 49 is 7. It's a perfect square. Finally, right triangle, doesn't matter how I draw it, as long as it's the right triangle with a leg of 5, hypotenuse of 8, and we're missing a leg. So we could use any variable we want, but this is the equation that we should end up with. Solving it as it states can be done by squaring everything. My gosh, if you've got great number sense, look at how quick that can be. Taking 25 away from 64 gets us down to 39. And the square root of 39, we don't know. And because it's on a right triangle, it's a length, and it's positive square root of 39. That's the study guide. That's the key. If you have questions on it, make sure you ask one of us. We'll be happy to help you. But you know what? About ready to move on to geometry. Congratulations. And you're going to see some of these same ideas coming up then. And so we'll let somebody else take over in that class soon. We'll see you. Thanks for watching all the videos that you've seen.